In this episode, we're going to take the shared responsibility mindset and zoom in on the area that most often determines whether cloud security succeeds or fails: identity, keys, and access guardrails. In cloud and connected environments, attackers frequently do not need to smash through a firewall to cause damage. If they can obtain valid access, they can often operate through normal pathways, making their actions harder to detect and easier to justify as legitimate use. That is why identity and access become the control plane for everything else. Keys and tokens act like powerful credentials for services and integrations, and weak handling of them can quietly open the door to data exposure. Guardrails are the rules and boundaries that prevent risky configurations even when someone makes a mistake. Our goal is to understand what these elements are, why they matter, and how they work together to protect data without requiring you to memorize product-specific settings. Before we continue, a quick note. This audio course is a companion to our course companion books. The first book is about the exam and provides detailed information on how to pass it best. The second book is a Kindle-only ebook that contains 1,000 flashcards that can be used on your mobile device or Kindle. Check them both out at cyber.author.me in the Bare Metal Study Guide series. Start with identity as the foundation. Identity in cloud environments means the accounts, roles, and authentication mechanisms used to prove who a user or system is. This includes human users, service accounts, and automated workloads. A major beginner misconception is thinking that only human users matter. In many cloud systems, the most powerful identities are not people. They are service identities used by applications to access storage, databases, or other services. If an attacker compromises a service identity, they may gain broad and automated access without needing to trick a person. That is why identity hardening includes creating clear separation between human and service identities, limiting what each one can do, and ensuring that each identity is protected with appropriate authentication and monitoring. The simplest way to think about identity hardening is to treat every identity as a potential entry point and to reduce the damage that any single compromised identity can cause. Authentication is the first line of defense for identity, and strong authentication is more than a password policy. Multi-factor authentication is a key concept because it adds an additional requirement beyond something you know. However, multi-factor alone is not a cure-all. Attackers can steal session tokens, trick users into approving prompts, or exploit legacy systems that bypass stronger checks. That is why modern identity hardening also includes adaptive access decisions based on context. Context includes device health, location patterns, time of day, and risk signals. If a login attempt appears unusual, additional verification or restricted access may be appropriate. For a beginner, the important idea is that authentication should not be a single static gate. It should be a flexible control that becomes stricter when risk is higher, while still supporting normal work when risk is low. Authorization is the next layer, and it answers a different question than authentication. Authentication asks who you are. Authorization asks what you are allowed to do. Many cloud incidents occur not because attackers bypass authentication, but because authorization is too permissive. If an account can read all data, then any compromise becomes a full data compromise. Least privilege is the principle that identities should have only the permissions they need to perform their tasks, and no more. In cloud environments, this often means avoiding broad roles assigned widely and instead granting narrow permissions tied to specific resources. Beginners sometimes worry that least privilege will slow down work. In reality, it is a guardrail that prevents a single mistake or compromise from turning into a catastrophe. The idea is not to make every permission change painful. It is to make broad, unnecessary access rare and controlled. Now let's introduce keys and why they are such a big deal. Keys can mean cryptographic keys used to encrypt data, but they also commonly include API keys, access tokens, and secrets that applications use to authenticate to services. These secrets are often long-lived and powerful, which makes them attractive targets. If an attacker finds an API key in a code repository or a token stored insecurely, they can often access cloud services directly without needing to compromise a user's device. This is why key management and secret hygiene are essential. Key hardening includes limiting where secrets are stored, rotating them regularly, scoping them to the minimum permissions needed, and monitoring their use for unusual patterns. For beginners, a useful mental picture is that keys are like master passes that can open doors quietly. You want those passes to be hard to steal, limited in what they open, and easy to revoke if something goes wrong. Key rotation deserves special attention because it is one of the simplest ways to reduce long-term risk. If a secret never changes, then any unnoticed compromise remains valuable forever. If secrets rotate periodically, the attacker's window of opportunity shrinks. Rotation can be challenging because services may depend on those secrets, but the conceptual lesson is straightforward. Secrets should have lifetimes, and those lifetimes should match the risk. High-privileged secrets should rotate more frequently and should be protected more strongly. Short-lived tokens are often safer than long-lived ones because they expire quickly. That said, short lifetimes do not eliminate risk if tokens can be stolen and reused immediately. So rotation is one guardrail among several. When combined with least privilege and monitoring, it becomes much more effective. Guardrails are the third component, and they exist because even well-trained people make mistakes. In cloud environments, a single misconfiguration can expose data publicly or grant broad access unintentionally. Guardrails are policy-based controls that prevent risky states from being created or that automatically flag and correct them. Think of guardrails like bumpers in a bowling lane. They do not guarantee a strike, but they prevent the worst outcomes. Guardrails can include rules that prohibit public access to sensitive storage, require encryption for certain data types, or block the creation of overly permissive roles. They can also enforce consistent tagging and classification so that resources are easier to govern. The key beginner insight is that guardrails turn security from a constant manual struggle into a system-level safety net. They reduce dependence on perfect human behavior. A useful way to connect identity, keys, and guardrails is to view them as three ways of controlling access. Identity controls who can attempt access. Keys control how systems and integrations authenticate and prove they are allowed. Guardrails control what configurations are permitted in the first place. When these work together, they dramatically reduce the chance of accidental exposure and malicious misuse. For example, even if a user mistakenly tries to grant broad access, guardrails can prevent the change. Even if a key is stolen, least privilege limits what it can do. Even if credentials are phished, strong authentication and context-based checks can block unusual access attempts. This layered approach is the heart of cloud data protection, and it aligns with defense in-depth thinking you have used throughout this course. Beginners also need to understand the idea of privilege boundaries and why cloud privileges can be especially powerful. In many cloud platforms, permissions are not just about reading a file or running a program. Permissions can include the ability to create resources, modify network paths, and change logging settings. That means a compromised high-privilege identity can potentially turn off detection, open new pathways, and create persistent access. This is why privileged identities deserve extra protection. You want fewer privileged accounts, tighter controls on when they are used, and more visibility into their actions. Separating routine work from privileged work helps. If an administrator uses a privileged account only when necessary and uses a normal account for daily tasks, compromise of the normal account is less likely to immediately become catastrophic. The concept is simple. Protect high privilege more because it has outsized impact. Monitoring is the final piece that ties everything together. Hardening is not only about prevention. It is also about being able to detect misuse quickly. Identity monitoring includes watching for unusual login patterns, sudden permission changes, and unexpected creation of new roles or keys. Key monitoring includes watching for tokens used from unusual locations, unusual access patterns, and sudden spikes in resource usage that might indicate misuse. Guardrail monitoring includes alerts when someone attempts to create a risky configuration, even if the attempt is blocked. These signals become far more valuable when correlated. For example, a suspicious login followed by a new key creation followed by large data access is a strong story of potential compromise. A single event alone might be benign, but the sequence can reveal intent. Beginners should focus on the concept that visibility into identity and access changes is one of the most important forms of security telemetry in cloud environments. By the end of this lesson, You should understand that cloud data protection depends heavily on controlling access through hardened identity, carefully managed keys and secrets, and guardrails that prevent dangerous configurations. Strong authentication reduces unauthorized entry. Least privilege reduces blast radius. Key hygiene prevents silent service-level compromise, and guardrails provide a safety net against mistakes and risky defaults. Monitoring and correlation ensure that when something does go wrong, you see the signs early and can respond before major damage occurs. The decision rule to remember is this: whenever you evaluate cloud security, start by asking whether identities are strongly protected, secrets are tightly managed and scoped, and guardrails prevent risky access configurations before you worry about more advanced controls.
Thanks for listening. For more audio courses, daily newsletters, and more, please visit DailyCyber.News.